All right, guys, back at it for the second day of week 6. And let's see, we did some trigonometric equations yesterday dealing with sine and cosine. We want to take a look at some trigonometric equations that deal with, other trigonometric functions. So we'll start with one with tangent. And again, I'm taking a look at this, and so I'm seeing this term and this term both have tangent of x in it, so why not get them together because they're similar. So if I bring this guy over here, all right, so if I go 7 tangent of x minus 3 tangent of x, that'll give me 4 tangent of x equals negative 4. And then if I divide by 4, okay, I'm going to get tangent of x equals negative 1. Okay, now, first off, remember that tangent has a period, okay, that's only pi radians long rather than being 2 pi radians long. Okay, so sometimes you'll see this solved on the interval from 0 to just pi, okay, like that, because technically one period of tangent is just pi radians long. Okay, other times you'll see people that say, well, we do sine and cosine from 0 to 2 pi, so let's do tangent from 0 to 2 pi. So you might see it solved on the interval from 0 to 2 pi, or just like yesterday, you might see it solved on the set of real numbers. Okay, so you got to make sure that when you're doing these problems, you pay attention to the directions. This would be 1 period of tangent, this would be 2 periods of tangent, and this would be obviously over the set of real numbers. So we'll take a look at that and we say, okay, I need the tangent to be negative 1. Now remember, tangent is sine over cosine. So this is the same as saying, okay, sine of x over cosine of x equals negative 1. Okay, so that means that on the unit circle, the x coordinates and y coordinates have to be opposites of each other. Because remember, the y coordinate is sine of x. This is your y coordinate. Okay, and your x coordinate is cosine of x. So that's your x coordinate. Okay, so to get this ratio, which is the tangent ratio, equal to negative 1, these guys have to be opposites of each other. Okay, so we look on 0 to pi. Okay, so from 0 to pi. Okay, the only place where we get the x coordinate and y coordinates to be opposites of each other is at 3 pi over 4. So if I went the y coordinate over the x coordinate, I'd get negative 1. Over here, notice they're exactly the same. So if I went the y coordinate over the x coordinate, I'd get positive 1. Okay, so on 0 to pi, I only have one solution at 3 pi over 4. Okay, so x equals 3 pi over 4. Okay, all right, so now if we go from 0 to 2 pi, okay, well, not only do we have this guy at 3 pi over 4, but notice we'd have this guy down here at 7 pi over 4. Okay, so we'd have 2 solutions there. Okay, 3 pi over 4 and 7 pi over 4. Okay, so here we would have x equals 3 pi over 4 and x equals 7 pi over 4, like that. Okay, now, when you go to the set of real numbers, I would go back to here and remember that the period of tangent is pi, okay, not 2 pi. So I would take the 3 pi over 4 and add all multiples of pi, not just the even multiples, but also the odd multiples. So we can say x equals 3 pi over 4 plus n pi, okay, where n is an integer. Okay, and you say, okay, well, what about this guy, the 7 pi over 4? Well, technically, it's included in here. So if we take a look, if we go 3 pi and if we add pi radians, that'll take us down here. So if I go 3 pi over 4 plus 1 pi, that would take me to there. if I go 3 pi over 4 plus 2 pi, that would take me here and then all the way back around, okay? Technically, this guy right here includes this guy when n equals 1, because 3 pi over 4 plus pi would be 3 pi over 4 plus 4 pi over 4, which would give you 7 pi over 4, okay? So that's probably the best way to do it. Okay, so that guy's done. All right. How about we try one of these guys with cosecant? Okay. All right, so let's see. I've got this guy here and I've got that guy there. Let's get them together. So I'm going to bring this guy over so that my coefficient stays positive. Okay, so I bring that guy over, so 5 cosecant of x minus 2 cosecant of x. I'm going to get 3 cosecant of x. Okay. And so if I'm collecting the cosecants on the right, let's collect the constants on the left. And let's bring that guy over. Okay, so that would give me radical 3 plus radical 3, so that would be 2 radical 3, like that. Okay, and then I divide both sides by 3, so I'm going to get the cosecant of x equals 2 radical 3 over 3, like that. Okay, so let's make sure we got that right. So let's see, that gives me 3 cosecant of x. Add that, that's 2. Okay, divide by 3. Okay. Now, if we're going to use our unit circle, we need things in terms of sine and cosine. Okay, so if I take the reciprocal of both sides, okay, the reciprocal of cosecant of x, okay, would be sine of x, and so that would have to be the reciprocal of this guy, 3 over 2 radical 3, like that. And then you're looking at that and you're saying, okay, well, how about we rationalize here? So I multiply by radical 3, multiply by radical 3, okay, and so I get 3 radical 3 all over, that would be 2 times 3, or 6, and then I can reduce this right here and here, okay, so I would get radical 3 over 2. So I get the sine of x equals radical 3 over 2. Okay, so remember, this is my y coordinate, okay, on the unit circle. Okay, so 1 period of pi goes from 0 to 2 pi. So we could solve it on 1 period like that, or we could solve it over the real numbers. Okay, so we are going to the unit circle, and I want to figure out, okay, when is the sine equal to 3 pi over 2? Okay, so I go to my unit circle. When is my y coordinate 3 pi over 2? Well, notice that happens right here at pi over 3, and it happens right here at 2 pi over 3. And notice if I go down here to quadrant 3, notice now it's negative radical 3 over 2, which I don't want. I want positive radical 3 over 2. And right here at 5 pi over 3, again, it's negative radical 3 over 2. I want positive radical 3 over 2. So that happens at pi over 3 and 2 pi over 3. These two right here. Okay. So let's see. My two solutions would be pi over 3 and 2 pi over 3. Okay. So if we're going over the set of real numbers, then I would have to add multiples now of 2 pi, okay, because we would have to go all the way around the horn to get another one. Okay, so that would be x equals pi over 3 plus 2n pi, or x equals 2 pi over 3 plus 2n pi, where once again n is an integer, and that accounts for not only rotating in a negative direction, but also rotating in a positive direction. Okay, so we're good there. Okay, let's try secant. Okay, so let's see, we're going to bring this guy, we're going to bring him over to the left and collect the 6 secant with the 4 secant. So if I'm collecting secants on the left, let's get the constants on the right. So let me bring this guy over right here. Okay, so let's see, 6 secant of x minus 4 secant of x would give me 2 secant of x equals, and then let's see, negative 5 radical 2 plus 3 radical 2 would give me negative 2 radical 2. Okay, divide by 2. Okay, so I'm going to get secant of x equals the opposite of radical 2. Okay, again, remember the unit circle, it's all sine, cosine, so let's take the reciprocal here. So the reciprocal of secant would be cosine. So that means that cosine of x equals the reciprocal of this guy, the opposite of 1 over radical 2. Okay, so we rationalize here, and I get the opposite of radical 2 over 2. So I'm trying to figure out when will the cosine of x be equal to the opposite of radical 2 over 2. Okay, and I can go right to the unit circle, so once again we will do that from 0 to 2 pi, and then we will do that over the set of real numbers. Okay, let's see what's going on here. So I want cosine to be negative radical 2 over 2. So remember, this guy right here is your x coordinate. Okay, so when was my x coordinate negative radical 2 over 2? Well, let's see, that'll happen right here at 3 pi over 4. And that'll happen right here at 5 pi over 4. My x coordinate is negative radical 2 over 2 in both of them. Notice over here, the x coordinates are positive radical 2 over 2. I don't want that. I only want negative radical 2 over 2 for my x coordinates. So at 3 pi over 4 and 5 pi over 4. Okay, so my two solutions here, x equals 3 pi over 4 and x equals 5 pi over 4. Okay. And then just like the last one, if we want to solve it over the real numbers, I have to keep adding the even multiples of pi, so multiples of 2 pi. Okay, so this would give us 3 pi over 4 plus 2n pi, and it would also give us 5 pi over 4 plus 2n pi, okay, where obviously n is an integer. Okay. All right, so that's good. We got time for one more. Let's get one more out of the way. And let's do a cotangent. Okay. All right, so let's see. Let's bring this guy over here. So if I'm collecting cotangent on the left, let's collect the constants on the right. So that guy goes there. Okay, so let's see. 7 cotangent of x minus 4 cotangent of x, that would be 3 cotangent of x. And then negative 5 radical 3 plus 2 radical 3 would be negative 3 radical 3. And I divide by 3, so I get cotangent of x equals the opposite of radical 3. Okay, so now remember, cotangent is cosine over sine. So that would have to be cosine x over sine of x. Gives us negative radical 3. Okay, so let's go to the unit circle and see what we can come up with. Okay. Well, it's definitely not going to happen in quadrant 1 or quadrant 2, because notice in quadrant 1, all the coordinates are positive, so if you go a positive over a positive, you get a positive. And down here in quadrant 3, they're all negative, so if you go negative over a negative, you get a positive. But notice we need to get negative. So it has to happen either in quadrant 2 or quadrant 4. Okay, so I'm looking at what we need, and I got to go cosine over sine. Okay, so if we look here at 3 pi over 4, that gets thrown out because these guys are opposites of each other. So when I go the x coordinate over the y coordinate, I get negative 1. Same thing here. Down here at 7 pi over 4, this guy gets thrown out because if I go x over y, cosine over sine, they're opposite, so I'm going to get negative 1. So it's either happening at these two guys, 2 pi over 3 or 2 pi over 3 or 5 pi over 6, or it's happening here at 5 pi over 3 or 11 pi over 6. So I got to figure out, well, which one of those is going to give me this guy. Okay, so let's see what happens. So why don't we just do a little investigating? So I'll start at 2 pi over 3, and we'll do cosine over sine and see what happens. All right, so at 2 pi over 3, okay, my coordinates are -1/2 and radical 3 over 2. And remember, your x coordinate is cosine. Your y coordinate is sine. Okay, so to get cotangent, I've got to go my x coordinate over my y coordinate. Let's see if it'll give me that. Okay, so I go my x coordinate, -1/2, over my y coordinate, radical 3 over 2, like that. So that's going to give me -1/2 times 2 over radical 3. So these cancel, and I get the opposite of 1 over radical 3, which gives me negative radical 3 over 3. So you see, I don't get what I'm looking for. So it doesn't happen at 2 pi over 3. So that guy gets thrown out. Okay, so let's see what happens if I take these guys and I switch them. Let's try 5 pi over 6. Okay, so let's see. At 5 pi over 6, okay, my coordinates are negative radical 3 over 2 and 1/2. Okay, and again, remember I'm going cosine over sine, so it's going to be x over y. So if I do negative radical 3 over 2 over 1/2, that will give me the same as negative radical 3 over 2 times 2 over 1. And notice these guys cancel, and I get negative radical 3. Okay, so this guy works out. Okay, so you see how I have to have the radical 3 over 2 as the x coordinate and the 1/2 as the y coordinate. Okay, all right, so that's going to happen here. So let's see, where else will that happen? Okay, it'll happen right here at 11 pi over 6, because here I would have positive radical 3 over 2 and -1/2, but I get the x coordinate over the y coordinate, and again, it will give me negative radical 3. Okay, so let's see. So this guy, from 0 to 2 pi, we know x could be 5 pi over 6, or x could be, let's see, what was it, 5 pi over 6 and 11 pi over 6. Okay, and so if we want to go the set of real numbers, okay, that would be x equals 5 pi over 6 plus 2n pi, or x would be 11 pi over 6 plus 2n pi. Okay, where obviously n is an integer. Okay, so we had to work at that one a little bit more. You know, you had to do a little bit of investigating here, okay, to figure out what's going to work on the unit circle. So a little bit tougher there. Okay, we will call it a day, and obviously I'm sure that you guys are noticing how important this unit circle is. I know I've been telling you that since last year, but certainly you can see doing these problems how important it is to understand how to use this guy. All right, you guys stay safe, and I miss you a whole bunch.